Welcome to Legacy Code Rocks, the podcast that explores the world of modernizing existing software applications. I'm your host, Scott Ford. This show is out to change the way you think about legacy code. If you're like a lot of people, when you hear the phrase legacy code, it conjures up images of big mainframes and archaic punch card machines. Well, that's true. It only tells a small part of the story. Anything that someone else has left behind is their legacy. And today on the podcast, we have Dr. Daniel Sturtevant. Daniel received a PhD in engineering systems and a master's degree in engineering and management from MIT. He's the co-founder and CEO of Silverthread, focusing on understanding complexity in large-scale software systems, developing methods for quantifying technical debt, and creating tools that help organizations build insight, reduce risk, and improve business outcomes on difficult software projects. Over the past 7 years, he has created system dynamics models to explore important social, economic, and workforce issues. Dan, welcome to the show.
Hey, thanks. Appreciate it.
Awesome. So we got connected through Declan, who's been on the podcast, and you worked with Declan on the Agile Alliance's efforts to kind of quantify and kind of give definition to technical debt.
Yeah, absolutely. Declan's a great guy. Worked with him and his group to think through what technical debt meant from the perspective of Agile, because a lot of the work that was done in the Agile community at first didn't really think through the health of the software application, certainly at scale, and how that would impact sort of your project performance. So it was a great project to work on with him.
Awesome. So was this older systems and messy code bases? Was that part of the research that you did when you were you're part of your master's and PhD program?
Yeah, absolutely. So I was actually looking at some large commercial code bases over the course of the dissertation with hundreds or thousands of people working in them. Maybe they'd have a decade or more of history to them. And actually measuring the health of those code bases from a technical debt standpoint, the code quality, the architectural health of the system, using some metrics invented by some people that are at Harvard Business School, and then connecting that with information you could glean from project management systems like version control systems, issue tracking systems, and quantifying how technical debt impacted developer productivity, defect density, and even things like staff turnover. Right? It turns out that architectural problems in a code base have a big impact on developers' productivity, and we even saw a 10x difference in the rate at which developers were basically quitting or being fired based on whether they were working in really healthy code or whether they were working in code that no one wanted to work in.
Oh, that's fascinating. That because I feel like my experience is that I've certainly seen people quit because of a code base that's too hard to work with or too challenging. But even people being let go because of it, that's kind of part of the correlation there.
Yeah, well, you think about it. I mean, developers, there are not enough developers and too many developer jobs out there. So they could hit the street, throw their resume in the air, and get 4 job offers by the next Monday. Life is too short if you're working in a terrible system. One of the other challenges is that if you are constantly fixing bugs, if your projects are always late, managers will come down on people and think they're bad developers because they're working on something that is just fundamentally hard to maintain, but they'll be blamed for it over time. And that's just not a good spot to be in. So it's a difficult challenge when it's hard to communicate about these kinds of things between the management people who are worried more about finance and delivery and schedules versus the people who understand the elegance of the code and how that impacts things. It's hard for them to communicate effectively with each other about those kinds of problems.
Awesome. I'm curious, did you find any kind of correlations that you found surprising? Or this doesn't have to be part of your research. It could be some of the work you've done with Silverthread as well.
These kinds of things are things people intuitively understand. They know them, but without the ability to really say, because of these challenges in the code base, we lost X $1 million last year, or we were only a third as productive as we could have been. Everyone knows those challenges are there, but they kind of ignore them. And because that poor decisions are often made, and it goes both ways, right? Sometimes it's your development organization will be telling management, screaming about, we've got to clean up this technical debt, and getting no support for that. And other times you're talking to executives who are just very frustrated about the rate at which things are going. And often they come in with process-related solutions, right? They want people to use, Scrum, right? they think that having stand-up meetings and pair programming and sprint-based development is going to speed things up, and often it can't, because often that's not the limiting factor. So, people don't tend to recognize that when they're in the heat of battle.
So it almost sounds like the two audiences could even be talking past each other, where one can be saying, we need support for these technical practices, and instead they're getting responded with process-based solutions.
Yeah, and often the challenge is that you manage what's measured, and 99% of what's measured often is your project-related things. You're looking at Excel charts with green and yellow and red, and you're looking at deliverables and how quickly things are produced. And if you're managing to that, you're ignoring the other half of the coin, which is the technical debt you've built up that is strongly influencing those outcomes, because people are only looking at and having conversations about the process related data that they have. They're ignoring that whole other piece of it.
Awesome. What are some of the things that you measure with your tools that you all have at Silverthread? What are some of the things that you look at to try to improve that situation?
Yeah, so there are a lot of code metrics out there that have been around since the 70s, right? There are code quality measures that are commonly used. I think McCabe came up with cyclomatic complexity back in the late 70s, and that's a great one, because every time I measure McCabe complexity and correlate that with defect density, you get a doubling or tripling of defects based on whether you have low complexity code or mid-level or high-level complexity code. So those kinds of things matter, but philosophically, when you're thinking about code quality, code smells, the types of things you're going to get out of SonarQube, you're in effect measuring the strength of every brick in a house, right? You're looking for issues on a particular line. You're looking at complexity measures associated with a function or a method or a class, but you're thinking about those things in isolation individually. And that's important, but it's not the only thing that's going to tell you about the quality of the house. You also want to know how those bricks are arranged. You want to know about the strength of the mortar. So when you're thinking instead of bottom up, like you are with code quality measures, there are also metrics, some of which were invented by Alan McCormack and Carlos Baldwin at Harvard Business School, using graph theory to reason about the relationship between those parts. So if you think about a code base as a collection of entities and relationships between them, I've got a function that calls another function, or a class that subclasses from another one. You can draw that as a graph, a directed graph. And then from there, you can use algorithms to figure out which parts of this code base are modular and have tight APIs and have good reuse, versus where do you have spaghetti architecture, right? Where A calls B calls C, and then that calls back to A. And you can reason about that at multiple levels. So we're thinking both about code quality measures bottom up and architecture measures top down. And a third thing that I'd say is very important, and we found it statistically, is the quality of your test coverage. Right? Do you have good unit system tests, especially automated ones? Those three things together, I think, are great measures of the health of a code base itself, as opposed to a health of the process.
Nice. So I've been lucky enough to see a demo of some of the tools that you have at Silverthread. And one of the things I noticed was that you also have the ability to aggregate some of these metrics across code bases. So I'm kind of curious, what that process is like, because I imagine that's really beneficial for people who are responsible for more than one code base, and also can help teams kind of see how they're doing relative to each other.
Yeah, exactly. It's one thing to say, you have high complexity code, you have architecturally challenged code, but just having a raw score isn't as helpful as if you have benchmarks. So we've got 7,000 other systems that we'll compare a code base against, and we can compare it against a basket of code bases that we have, or against other code bases inside the same organization, so that you see where they rank. And that kind of tells you not only where you rank, but what's really possible, right? I don't like to think about quality in absolute terms. I like to think about, how far are you from, say, the top 10 percentile in terms of code bases that are similar sized and similar language, because that's where it's realistic maybe to get to if you intervene with some refactoring or some rewriting. And then we can think about what's the cost of getting from point A to point B, and what's the benefit of doing so in terms of, how much are you going to improve your life, become saner, much faster will you be able to move inside this code base? How many fewer defects will you have? We want to compare against realistic expectations instead of some absolute ideal that every code base should be pristine, because that's not going to happen.
Right. It'll be like an asymptotic, idealistic point that'll never be reached, almost like, for many systems, that's 100% code coverage. Like depending on how it's architected, or depending on what subset you're measuring, that can be asymptotic.
Mm-hmm. Absolutely. Right. So I want to see what's best of breed out there, and where does it rank, and what can you expect in terms of your business outcomes in those kinds of code bases, to think about, okay, where do I want to be, and is it worth it to get there? And maybe it's not worth. One hard question is, given a code base in its current state, should it be rewritten or should it be incrementally improved? And you got to think through, okay, what's going to be the cost of both of those options, using cost measures and also other strategic considerations. If you can make that decision in a better model-driven way, you can save a lot of people's time.
Yeah, and that's a question I get a lot, and I feel like I kind of have a hand wavy solution that I point people to. So it's more of a feeling and instinct based approach. So like to hear that like there are models that can be relied on to get answers to that is really nice to know.
Yeah, it's been really interesting to come up with those models. Worked with one of our co-founders is a finance professor, and she invented the model that we use, because you want to think about a return on investment, right? The return is what, over time, if I improve this system, how much more productive are people going to be? How much less downstream risk? How many fewer bugs? And come up with a way of turning that into a dollar figure. You think about the present value of that future stream of benefits, and you compare that against your expected cost of doing a rewrite or incrementally improving, and then all of a sudden you can make a finance-based argument for taking a course of action that has dollars tied to it. You can actually have a reasonable conversation with a CFO about that once you've done it, and compare it against other types of things you might invest in. Right? So when you're talking about technical debt in software, now we can talk about it in terms of other forms of debt or other investments that people might make in something else the organization cares about. So all of a sudden you're putting software improvement on the same plane as other kinds of investments that your financial people would be thinking about.
Nice. And I'm curious if you've seen correlations between quality, either good or bad, in either different language communities, and also kind of the other axis would be size of the code base. So for example, is it such that really large code bases tend to be really bad, or code bases and I don't want to pick on any particular language community, but pick language community X and code bases in that community tend to be pretty poor? Have you discovered any of that?
Sure, absolutely. I mean, we've only been doing software for 50 years. We've been building bridges for thousands of years, so we have pretty good sense of how to do bridges. No one should feel bad if they built a code base at software in a lot of ways is still in its infancy, and it's the most complex thing that humans have ever set out to create. And it's sort of purely a cognitive thing, right? You're thinking through what to put down in this editor, and it really is a reflection of nothing but people's ability to create a mental model in their brain of what they want to happen, and think through what steps to put in code to make that occur. And unlike other things that we build as humans, there's no repetition, right? If you design a building, it's a lot simpler because, okay, I've got 1,000 windows. Well, I only have to design one window, but every single piece of software in principle is different. Otherwise, it's code duplication. That's a bad thing. So as these things, things that we build up over time get more and more complicated, it's more and more challenging for anyone to have a good concept of what's really going on in there. So what we found is that languages that are older don't have as many guardrails in place to protect against architectural problems creeping in or other kinds of problems creeping in. So you're going to see nastier stuff in COBOL, and you're going to see nastier stuff in C than you do, say, in Java, right? Because Java was designed with more of those guardrails in place. So we do see a systematic difference. C code bases, given the same size and the same age, tend to have more architectural problems than Java code bases, for instance. And I think that's just a function of what we've learned in software engineering over time.
Interesting. And that's almost like a kind of validation point for those guardrails being created in the first place. Where kind of, the assumption was that, the adage was that C provides you too many ways to shoot yourself in the foot. And C had a lot of them, or has a lot of them. Whereas Java was trying to take as many of those away as was feasible and still allow you to be productive.
Yeah, right. So some of the later ones, we've had different concepts of modularity over time, right? The idea, object orientation is this sort of extreme form of modularity, if you will. But putting different kinds of guardrails in place in terms of the language paradigms we have, and also just specific language constructs, has been helpful. Even things like now we're thinking about microservices, the idea that you're going to have these modular boundaries around applications themselves that provide guardrails and stricter APIs between them, naturally enforces some of the types of things that you want to do to maintain a healthy system. But these things are still being invented, and we're still figuring it all out.
Yeah. I like anytime I get in a conversation with somebody about the similarities and differences between building software and building physical structures, I always think about like material science and just how, like, as when we're creating software, we're like inventing the material as we're using it. There are some, libraries and things we're able to lean on, but for a lot of it, we're inventing it as we go. And I think that that's something that's very different with physical construction that you don't see.
No, that's a great point. I mean, in traditional engineering, you're constrained by the laws of physics, right? So when you're designing, you're really fighting against these physical constraints that put a lot of pressure on your design choices. In software, your challenge is that you have too many options, right? You can do there are too many bad ways that you can screw it up, and so discipline has to be self-imposed as opposed to imposed by heat and Newton's laws and everything else.
Yeah, when I was much younger in my career, and I would be asked if something was possible, like my answer was almost always yes, because I didn't understand what was really being asked was, is this possible within a reasonable amount of time and budget?
Mm-hmm.
Because like, oh yeah, it's all possible. It's like, how hard do you want to work at it?
Yeah. Well, and in electromechanical systems, often they'll try to compensate for problems in the physical design by saying, we'll just solve it in the software, right? So now your software is all messed up, but people think of that as something that's obviously more malleable. It's soft. So you have these unlimited choices that you can really kind of dig your own grave in the long term with it.
Do you all see any kind of issues crop up with like reliance on dependencies? Or you said like you look at modularity. Is there kind of any issues with some of the modules that you're depending on being too fragile or not getting updated? I'm curious about anything that you measure around that.
Yeah, I mean, I'd say, let me put it this way: in an ideal system, an ideal software system, you want to have a structure where you've got a collection of modules with high cohesion internally that maybe do one thing and do one thing well, right? And you have tight APIs around it that are controlled. And then you want those modules to be arranged in a hierarchy. So there's a clear top and middle and bottom. Maybe you think about it in terms of layering or platforms. So maybe you have these hard, rigid boundaries between those things. But generally you want the dependencies to flow in one direction from top through middle through bottom. At the top, you've got your GUI or your APIs. Middle, you got your business logic, your middleware. At the bottom, maybe you've got your utilities. And the nice thing is if your utilities are generic, then they can be reused across applications. And you want to have the things lower in the stack have more stable APIs and less change going on and more controlled change going on, so that you want your most mature stuff and generic stuff to be at the bottom. And where we find people run into problems is where they're intermingling the business logic and even the GUI stuff with what should naturally be extracted out as utilities that are generic. And if you've got circular dependencies between those different parts of a system and you kind of mix up that logic, then you're going to have more churn at the bottom of your stack than you should, and it's going to be more fragile.
And again, that's that cycle is something you can look for using graph theory.
Mm-hmm.
And so I guess that gets to the question of I imagine you have like really robust parsers for these languages to be able to map out all those connections between pieces and parts.
Yeah, we're certainly dependent on the parsers, and now we're using different static analysis parsers for different languages. Our tooling, we integrate with third-party tools that do the parsing of different languages, and some do better than others. But yeah, we've got to get those dependencies out. And once you get them out and you kind of scope up or down, looking at a graph, we can trace out places where people have violated different kind of design patterns, right? Model view controller, for instance. I've seen applications where it was clear that down in the model or the controller code, there were dependencies or calls back up on stuff in the view. And it's because people in the heat of the moment when they were changing the code base, they got creative and they said, well, someone at the top of the stack implemented something that was really cool and useful, and we're just going to reuse it instead of extracting it out and pulling it down lower to break that kind of cyclicality. And they might have gotten the job done much faster in the short term, but they tied it up in such a way that now, let's say you wanted to replace the GUI, you strip it off and all of a sudden you're removing a bunch of the business logic that the application depends on. So I've seen applications that couldn't move forward in terms of their look and feel because they had tied it up in those kinds of ways.
Interesting. And that kind of like brings to mind a graphic that I've seen in some of Declan's presentations where like it's kind of like a systems diagram that shows like, the problem, the fundamental fix, and then kind of kicking the can down the road. And that's very much sounds like the situation that you were describing where like the fundamental fix was to extract out that logic, but the kick the can down the road was to just go ahead and use it where it's at.
Absolutely. And you get in these larger code bases with 100 developers or 1,000 developers. They've been around for 10 years. Maybe you had an original architect who designed, laid out the concept of the system, but move forward a few years and no one remembers that. And you throw interns into the mix and people are just trying to make local choices that get the job done so they can go home on Friday. And in general, they'll pat themselves on the back if they can get something done a week quicker by being creative. And this is why technical debt happens. You're making short-term optimal local decisions at the expense of this global ideal, which maybe people don't even see or recognize because in these large code bases, you can't mentally trace out all of these things. You don't really understand all of what's going on in that code base. You just know you're a little part of it. So our tools help people actually see the global view and understand how the local decisions are impacting that so that you can make wiser long-term choices.
Awesome. What are some ways that you help kind of visualize that?
Well, there are a few different ways. I mean, there's if you use traditional graph notation, you see nodes in a picture as dots, and those might be each class or function or file, and then you get arrows between them, right? So if there's a arrowhead pointing from A to B, it means that function A is calling function B, for example, and you can look at that in the aggregate. The challenge with that kind of view is that you go and you look at some of these internet diagrams that are colorized, and they can be quite beautiful if people plot them all out and render them in a cool way using like string theory or string relationships. The problem is they're beautiful, but they're useless because you can't see anything. There's a different notation that we use that's a matrix notation. Some people call it an adjacency matrix. Other people call it a design structure matrix. But it allows you, if properly sorted, to actually see most of the important architectural features of a code base or any other kind of physical system where you might want to plot out the relationship. So we use those a lot internally. It's a notation people have to get used to really get the value out of it. But that's one of the things we do as well.
Gotcha. And I'm curious, do you provide any tooling to help teams kind of see like how they're doing over time and kind of like assess whether or not things are moving in the right direction or not?
Yeah. So we've got 3 products that we're selling right now. We call it our tool is called CodeMRI, and we've got the CodeMRI platform. And on top of that, we've got a portfolio product intended for those executives overseeing 100 or 1,000 simultaneous development projects, and you can look at trends over time on key high-level metrics, but then drill into individual systems and see improvement over time as well. We've looked at the history of applications as they degrade, going back 15 years with people, and then also use tooling to make recommendations about what to do inside this architecture to improve it, and watched all the metrics get better, both on the technical front, with the technical metrics that we can extract from the code base, but also we've seen improvement on business performance that happens after people fix up these code bases because they're getting a lot more productive.
Oh, that's and I imagine that's incredibly useful for people who are kind of in the C-level of these organizations to see that like not only is the return on investment in terms of like how productive the team is, like the software team, but also the rest of the business is able to reap some return on that investment.
Yeah, I mean, I can tell you a story of one team that was using these tools. We Java system, I think it had 10 years of history to it, and it had just gotten, the whole engine had seized up. We were able to look at 15 or 10, 15 years of history on that to watch the complexity growth over time. But then we were using these graph theoretic tools to make recommendations about what to do. And basically they're finding the anti-patterns, the architectural anti-patterns in this code base and pointing to, a prioritized list of what to attack to get this thing to move in the right direction. And what was cool is over the course of 4 months, they completely eliminated the architecture problems that we identified. And the ROI models before the project was started said that that team should be 2 to 3 times as productive as they are now if they make those improvements according to the models. Said they were at the 20th percentile and the target was to get to the 80th percentile. What's cool is after the fact, after that 4 months, they said the project had already paid for itself because they really were 2 to 3 times as productive because they're just not tripping over themselves anymore. They said the APIs in the system all of a sudden behave as expected. They weren't having places where every time you poke it in one spot it breaks something else. What was interesting is that team had a giant README file with all the tips and tricks of how to work in that code base that all the developers who had been there for a long time, they kind of knew some of that, but they had to write it all down. That README file was printed out in binders, and that binder was about 2 inches thick.
Oh, wow.
They were able to throw that binder away because, again, now the local parts behaved like they should. They talked about now they can bring in new developers and not worry that they're going to trash the whole thing because they're making mistakes or changing magic numbers that are arcane. So, getting the APIs under control, getting the dependencies under control, and making it so that they can make localized changes without having sort of these emergent properties or side effects killing them was huge.
And it's something I'm curious about in terms of like cleanup approach. Do you advocate for teams kind of halting the presses on features and really kind of tackling these fundamental issues, or is that something you see can be done in tandem with other work?
Well, so that team, after we did the ROI analysis on it and got the go-ahead basically they got the go-ahead to continue spending 70% of their time on normal feature development and bug fixes, but spend 25% of their time on attacking the architectural issues. So they got the mandate to do it. And we're able to do them in parallel. So our tooling was spitting out a list, at first of maybe 50 to 100 anti-patterns to attack. And they looked at that list and they would, in each sprint, maybe pick off 5 of them. And what was interesting is that our system doesn't know what the code base does. It just knows about its geometry. And we did some work to optimize the recommendation algorithms, and they said that 95% of what we were recommending, it was a real issue, and 5% was false positive, but that's okay. And they started at first trying to attack the things that were highest on the list, but realized that was not terribly helpful. Then they switched to a different strategy. They picked things off the list that they considered easy to do, right? Something that would take half a day of developers' time or a day as opposed to a month. And they would clean those up. And then at the end of that sprint, rerun the analysis because now it's finding a new path through the system to find anti-patterns. And so over repeated sprints, working down some of these issues and cleaning up other things that they identified along the way. If you see something bad in one spot, go fix it everywhere instead of just the one place the algorithm identified. And what was interesting is the system was all tangled up. And at first there were some things on that list they thought were easy, some they thought were hard, and some they thought were impossible. But as they cleaned out the easy ones, they said that the hard things became easy and the impossible things became hard. So I don't know what's the word, analogy, metaphor, one of those that they used was it's like untangling fishing line, right? Have you ever taken your kid fishing?
Not yet, but I have untangled fishing line before.
Okay, so I've got kids, right? So your kid will pop a spool, and then you'll sit there for half an hour untangling while they take your rod, right? And and so you never actually do any fishing. Now, if you knew when you're trying to untangle that fishing line exactly which thread to pull in what order and in which direction, you would be done with that problem in 30 seconds to a minute. But because you're looking at this tangle and you're pulling wrong, it's going to take you half an hour. These algorithms are trying to tell you, which threads to pull in which direction so that you can do it faster. And it was really interesting to see that because, they said that they were able to get this thing done in a much more straightforward way than they thought was possible because they were just sequencing things. And it was an amazing result that the things that were hard became much easier when all the cruft was pulled out of the way.
That's a great story because you said this team turned things around in 4 months, but they had, their budget was 25% of what they normally spent on normal feature work. And so that's just a fantastic story that they're able to do that so quickly.
Yeah, and as you're decoupling different parts of the code base, all of a sudden the teams that are working in the parts that have been pulled out are becoming more productive. I was in a different organization where they had that experience. As soon as their team broke free from the knot that was tying everyone else up, that individual team became much more productive, even though the whole rest of the organization was still kind of in hell. But we saw the lights go on, if you will.
And the question that I have, especially for large organizations with a lot of projects, and maybe these are projects that talk to each other, so they are dependent on each other. Do the same meta problems start to show up at that level, where you have systems that are tangled up with each other, or systems that are cyclic?
Yeah. So we've seen that in our research. We've also looked at different code bases that interact because they're deployed and they talk to each other via web services, and now you're plotting out almost an enterprise architecture. The same rules apply if you think about each code base as a modular unit, and the APIs between them, or the calls, or the web services, inter-process communication, whatever. We're on a research project working with a large bank, and found that when you plotted out the dependency structure and looked at the different servers, the parts of the organization where it was all knotted up, those servers had more downtime. Right? They had more bugs in those applications. And it wasn't predicted by the quality metrics for the code inside the individual applications. It was where positionally were they in the larger structure. So these type of impacts, scale up or down at all the different levels that you might think of.
That's interesting. So I guess you were talking about like the file level earlier, or the class level, or the function level, or if you're in a functional paradigm, maybe like the module, or that's really neat.
Yeah, and I mean, think about people are talking about microservices today, right? As sort of a panacea, but and it's one thing to decouple code bases and to put them into different processes and deploy them separately and have them call each other that way. But at the end of the day, if those microservices are arranged so their dependencies are hierarchical, you want each one of these code bases to be small enough that it's within the bounds of human understandability, so that people can work on them individually without mucking them up. And you want the dependencies also to flow from top through middle through bottom, and not to create cycles. Sometimes when people create microservices, they'll still have things that are too large, and they'll also have a situation where a call will go from one to the other, and also from the other back to the first one. And in my mind, that's not two modules. That's still just one module. You just now have a web API between it instead of something else. But at the end of the day, you're not solving the problem unless you use them to enforce the kinds of principles that we're talking about here in the first place.
Is there anything you feel like I should have asked you that I haven't yet?
Well, we've talked about code bases that can be improved. I guess one of the things, I've looked at for one of our major customers, Department of Defense, we've looked at portfolios of hundreds of code bases and characterized them using this language, and found some that were in great shape, right? And all of a sudden you can reward those teams with more work, or you can give them kudos for building things well. And when you interview people on those teams, you kind of understand why, because it's clear that the people designing and evolving those systems have a clear sense of the architecture that they are going for, and the practices they have in place around that, in addition to their agile development practices. There are, we've talked about systems that can be improved, right? And a lot of them can. I think there's a lot of room to incrementally improve the health of a code base if you know how to do it and you have tools in place to do it. Whereas traditionally they would have just gotten worse and worse and worse until they fail as a project. There's a third class of systems that maybe a small subset of them, where you just look at it and you say, okay, this thing's too far gone. Either the ROI models say that it's not worth it, right, to try to fix this thing, or algorithmically you're looking at it and saying, I've got 11,000 files that all depend on each other circularly. And it's just not technically possible to do it anymore. You wonder how it even functions. So there are definitely some systems out there where there's a lot of good money being thrown after bad, and people continue to maintain them. There was one where we did the modeling and predicted that for every $1 million spent on future development and maintenance, they were wasting $860,000. Right, and
Oh, wow.
that was at the time, that was the most challenged system that we'd ever seen, but we've seen one worse since. But once you know it, you can, say, okay, we're not going to spend another decade spending tens or hundreds of millions of dollars trying to improve this thing. There's this strong tendency to want to reuse stuff because you think it's going to save you money, but often building something new is actually the optimal thing to do. And what's interesting in that case is that there was a development team that was working on that system. They were brought in. They were a very good development team. They had a good history, but they just couldn't handle this code base. And management was beating them up over it. Everyone's getting demoralized. And when we analyzed it, we thought, okay, we're going into a difficult conversation here because we're about to call someone's baby ugly. And what we found is that all of a sudden, when we're able to identify the root cause of all the project-related problems, I mean, they hadn't even been able to get the system to compile in 3 years fully, right? Yeah, exactly. So the deployed version of the product was 3 years old because they couldn't deal with this code base. It changed the nature of the conversation because whereas before management was beating this team up and saying they sucked and people are quitting and everything else, all of a sudden you see that they didn't create the problem. It had been around for decades. And all of a sudden, instead of being, now you're having a conversation about giving these people combat pay because you did this to them, right? You put them into this system and asked them to maintain something. It was a nightmare. And now instead of, now you've got a much healthier conversation because you're not making it about the people. And, before we got there and analyzed the architecture, they thought, okay, first of all, it's the people, so we're going to yell at them a lot. And then they thought it's the process. So again, they sent them all off to Scrum Master training. Well, that didn't fix anything. Because if you ask someone to do sprint-based development with a 2 or 3 week sprint in a system where the models predict that any reasonable feature is going to take 84 days to complete, it's just not going to work with a sprint-based development process. It's,
you can't even compile.
Yeah.
How can you demo? Yeah.
Right, exactly. So there's no way that agile project management alone would solve the issue in this case, and in several of the other cases that we've seen. So by knowing that the technical debt was the root cause of their project issues, it allowed people to kind of all get on the same page and appreciate each other's work and struggles. So yeah, I'd say it's one of the really nice things that I've seen is that all of a sudden you're taking subjective conversations that are heated and political and hand wavy and turning them into objective conversations about the problems that everyone is facing. And when you get rid of when you add light to a situation, often you can get rid of a lot of the heat in the conversations.
That's awesome. And it kind of makes me curious whether or not you've encountered any teams that were even still resistant once they were shown either that it needed to be, the system needed to be thrown away, or that there was, enough ROI to be gained by improving it, but that they'd kind of already made up their mind which path they wanted to follow. I'm kind of curious if you've seen that.
Yeah, often. I mean, unfortunately, in the real world, I've got this nice argument about, everyone's kind of rational and enlightened about this, and they're just going to take what's the rational choice and go with it and check their egos. The reality is the risk you run is that when you're going into a system and showcasing some of the challenges, you might be calling someone's baby ugly, right? And people don't always respond to, often people want to bury that kind of information. They don't want to see it. And if they see it, they don't want it shown to anyone else, because unfortunately in some of these large organizations where this technical debt has accrued over time, things have slowed down. They're under competitive threat. The team and the whole organization might be underperforming in one way or another. And that can create some cultural toxicity that kind of interrelates with their process and their culture and leadership and everything else. And so sometimes in these organizations with a lot of technical debt, you've also got culture problems and low trust because it's built up over time. And so it is a challenge trying to work in those kinds of situations. Often we find ourselves in the role of software therapist, which I never thought I'd be in, but that's definitely a challenge. So
yeah, it's I can see that being an emerging need as more and more systems get built and
yeah,
maintained.
absolutely. How do you keep the developers of the world sane?
Yeah.
And yeah, absolutely. That's and often the challenge, when you're talking about the resistance, often the developers, right? They embrace this kind of stuff, and often, executives in a large enterprise will also kind of see the value and embrace it, and it's often sort of the middle management layer that has difficulty with it because all of a sudden they're feeling exposed and really doing things that help them out as well in their position is important.
So as part of that exposure, part of that feeling of exposure, is that coming from like feeling like the problems that have been illuminated reflect poorly on them, or is that?
Yeah, I mean, if you get people who've been in the organization for a while and you have a brand new way of showing problems, right? Like we talked about bridge building versus software building, and just the natural tendency in any complex system, right, is towards complexity, right, towards these things getting tied up, right. It's almost an entropy process. Left unchecked, these things will naturally emerge in any large code base. Modularity is not something that will evolve naturally. It's something that you have to work hard to maintain as something grows. But people take it personally and they think that it's a reflection on them. And one of the things to just highlight is that phenomena. The reality is that I think in the Agile community, Agile did a lot of really good things for the world, right? But one of the things that they had in the original manifesto, I think, was the idea that architecture emerges, right? We're just going to not document stuff and not worry about what the architecture is, and it's just going to naturally happen if you have good process and well-meaning people in place. And the reality is, a highly modular system at scale that doesn't emerge. Entropy emerges in a system. The forces that would tangle this thing up in knots are the things that are naturally going to happen. But people have seen that in the original Agile stuff and resisted the idea that you need to think about architecture at all because of it. So I think that's one of the failings of the sort of the original way people were thinking about Agile, and you still see that out there. So that said, what they were resisting was this old school, really heavyweight. We're going to design something for 5 years before we write a line of code and get it all in on paper. And that was the idea of what it was. So I agree that's no good. But when we're just thinking about, what's the geometry of a code base? Is it broken into small modules that have tight APIs and have a dependency structure that flows in one direction? That's kind of a minimum mandate, right? And if that's all you really care about, enforcing, then you're just putting rules in place that keep your system understandable by humans and make it so that it can evolve and adapt over time. If that's all you mean by architecture, then you're actually in pretty good shape, because no developer in their right mind can argue against the idea that their system should be modular. But we've got a lot of baggage that we've accumulated over the past 50 years, both in terms of code and the way we think about it, that we might have to figure out how to get past.
Well, this has been a fascinating conversation, and I feel like I could talk to you for another hour.
Yeah, I could too.
Or more. I think there's a lot more meat to this, but we'll have to leave it for another time. One of the things we like to ask everyone as a final question is, what's one thing that you love about legacy code?
Oh, I mean, it's great to see, what has been built before and keep it alive to reuse in the future. I mean, it's this interesting intellectual activity. Over the past 50 years, we've built up so much and we've learned so much. And the idea that there are these things that our predecessors built before us they're still actively in use that we can rely on allows us to kind of build up the intellectual stack and kind of stand on the shoulders of giants, if you will. Right. So if we can find a way to keep that stuff useful and in good order, then that's kind of respecting what they've done. So I like to think of it as this archaeology project, as you're looking back through time, going down through the layers of things from the past and seeing what we're leveraging now.
Awesome. And if people want to get in touch and maybe chat with you more and potentially hire Silverthread to help them out on their projects, what's the best way for them to get in touch?
Yeah, so I've got a website, Silverthread Inc. That's inc.com. And you can reach us through our info email there. So would certainly appreciate anyone who wanted to talk about legacy code.
Awesome. And for those of you listening, if this conversation has sparked ideas that you'd like to continue chatting about, we have our Slack community that you can join. You can get there by visiting slack.legacycode.rocks. While you're there, you can also find our virtual meetup channel. And the virtual meetup meets on Wednesdays at 1 p.m. Eastern. And it's just kind of a group of people who get together and talk about the challenges that they're currently facing on their projects. And I sometimes joke it's like a support group for people who are working with older systems. So that is a great way to connect with others and learn from others. And the chatter in Slack is also a great place to share ideas and get tips and tricks from other people who are like in the trenches trying to solve these problems day in and day out. And then we have a newsletter that you can sign up for at the website, legacycode.rocks, that we're working on kicking back up again. But for now, we'll see you on the next episode. Thanks.